Hello 108 students, Mr. McHugh back here with you. I'm going to finish up section 2.5 on page 3. I'm going to go ahead and talk about solution sets here, continuing from our previous page here. So I noticed on my notes I say check the table in the book, and I'm talking about the table that's on page 97, just to help you out there a little bit, what I'm talking about. So if you look at that real quick, you're going to see that you've got 4 different possibility of solutions here, and ultimately when you turn around and you find values for, you're going to either have x equals to a specific number. Now this is the example of the interval notation, and then here's the graph form. Again, I recommend you always do the graph first, but if it's exactly a value of x equals 2, you just draw your number line, find 2, and put a dot. If you have an example where your solution is x is less than 2, you find 2, and of course you're going to use the open circle, the open parentheses, and you're going to go to the left. In this case, again, notice there's no equal signs with these, so here's one with this x is greater than 2, so you find 2, give yourself a right hand parentheses, and you're going to the right because it's going greater than. And remember, everything to the right is positive, everything to the left is negative. Excuse me, I'm sorry. And finally, x is between negative 2 and positive 2. That's how you can kind of say that real fast. You look at this, x is greater than negative 2, so you're over here going this way. Then you're saying x is less than 2, you're finding this here, and you're going here. If you're going to graph them out, where do you find the overlap region? That's where x is in between. Okay, so we've got those here. That's just a summary there. Objective 4 we're going to talk about next here. Applied problems with linear inequalities. You got to get used to reading the words and translating them. X is at least 5. You would write that as x is greater than or equal to 5. If you had x is not less than 5, that would translate into x is greater than or equal to 5. These are a little tricky. You got to read these and think twice about it. X is at most 5. That means it can't be 5 or greater, so you want the values of x is less than or equal to 5. Finally, this one, x is no more than 5. X is no more than 5. That means you conclude the 5. You don't go greater than 5, so x is less than or equal to 5. Okay, so I just kind of recommend you study those a little bit. Those examples here are on the bottom of page 97. Also, this table, you can look at that too and study those. Okay. Just a little tricky when you read those, so you just have to practice them. I guess that's the best thing I could say. I'm going to do example 7 here. This is a case here where you need to cut down some trees. Hey, we just had some wicked storms out here on Tuesday, this past Tuesday. Find out that a tree blows down and you want to go cut it up. You want to go rent a chainsaw, and you go talk to the person there over the phone. You check it on the internet, and it says it's $15 to rent the chainsaw, and they're going to charge you $2 per hour for how long you're going to rent it. And I've rented chainsaws and other equipment here, and that's from the moment you finally sign out on the computer to when you bring it back. So keep that in mind. It's not how much you usually actually use it. The getting it back and forth is on your dime. So Tom, turns out he only has 35 bucks in his pocket, and he wants to figure out excuse me, what am I doing here? He wants to figure out how many hours he can do this. So here we go, the word problem, helping him out. Let H equal the number of hours you can rent. And so he has to have the total cost of the rent has to be less than or equal to $35. He can't go a penny over it. So there's your strategy equation to start with. And so let's break it down for him. Okay, he knows he has to spend $15 plus he's going to pay $2 for every hour, so 2 times H is less than or equal to 35. Now you've got yourself an algebra equation, and what can we do to isolate the 2H? We're going to minus 15 on both sides, and now we're left with 2H, 2 times H is less than 20 divided by 2, and lo and behold, H, the number of hours he can spend with the chainsaw, is 10 hours. So he now knows that basically he can get this done in a day, and he can probably estimate whether that's enough time to do the job or not. Okay, so those are the key thing was it has to be less than or equal. That's probably the hard part of that is which way you get the inequality sign. Okay, I squeezed in example 8 here in the bottom of this, and we'll wrap this page up. I like this one here. In the old days, before we had everything on electronic graded books, we would turn around and go to college and maybe take 3 test scores for a semester, and the 4th one might have been the final, and they were all equally weighted, and the person would figure what did they need to do to pull an A for a class. And the student turns around and realizes his scores were 88, 86, and a 90. He's doing good. He or she is doing excellent. Needs to have that 90 average to get the A for the class. What is the minimum score needed for that 4th test? Okay, so we got to go back and realize what average is. Average is you add up the numbers and divide by how many. So we turn around, we start this problem by saying here's the 3 scores, we add them up. The 4th score is what? We don't know yet, so we'll let that be the X. There's the first one, second one, third one. Here's the 4th one. When you find the average, you always divide it by how many that you took. So he's got to take 4 tests. And the key thing is this score has to be what? He needs to get at least a 90. So he needs to score, this average has to be greater than or equal to 90. If he gets a 90, he gets an A. If he ends up with an 89.9, he's going to get a B. So he wants to know exactly what he needs to get. Okay, so that's the hard part. Greater than or equal needs to go in there. Add up these 3 numbers. You get 264 plus X greater than or equal to 90. Okay. Next thing to do is to realize to multiply both sides by a positive 4. And that's because you're dividing by 4. It's a fraction. If you multiply by a 4 on both sides, multiply by 4, you're going to turn around. The 4's will cancel out, because this is all term here, and you get 264 plus X greater than or equal to 360. Now that's the key step to this problem. Once you realize when you divide by 4, multiply by 4 on both sides, you maintain equality, maintain balance. Now you can subtract 264 on each side, and you get X is greater than or equal to a 96. So that's how we used to do that back in the old days to make sure we got ourselves the A that we wanted. So and it worked hard to get. Okay, hey, I'm going to wrap this up here. This is the conclusion of page 3 of section 2.5. I will see you for the beginning of 2.6. Okay, I'll see you later. Bye.